So hi, everybody. Welcome to the webinar. So this is about how to get results incrementally from your graph data. So my name is Gerd Zellweger, and I'm a co-founder at Feldera. So what are we going to do today? So we're going to talk about three things. So first, we're going to look at kind of how to process graph data in Feldera with a use case that is a fine-grained permission system. So we're going to learn about this use case. And then we're going to see how we can model this use case in Feldera. And finally, we'll kind of run and explore this permission model that we're going to build together in the Feldera Web Console. So that's the key part, right? And so hopefully the main learning here is that we can see how we can model graphs as data structures in Feldera and how we can compute on them with Feldera. Okay, so to set the stage, I'm going to quickly kind of switch the gears here and show you my Google Drive, which is kind of the permission model we're kind of aiming to represent here in Feldera. So in this Google Drive, I can have folders, right? For those not familiar with, so it's just a file-based hierarchy. I can have subfolders and I can have files, and I can switch between them, right? So this is nothing special. We should all be familiar with this. But also something I can do is I can share, right, certain folders or individual files with other people or organizations, right? So if I click share here, I can go and I can, for example, give access to Lalit to my report here. And I can also give access to an entire group, right? And the other thing that's important to note is that the people or the organizations and groups I give access to can either be just viewers, like just having read-only access, or they can be editors, right, having access to read and view and write a certain file or a folder. And of course, if I give access to a folder, right, that includes all the descendants, so to say, all the subfolders and files under that folder. So if I would give somebody here access to accounting, they would be able to access all of accounting. So that's roughly it. That's what kind of the system we're trying to kind of mimic today and model today. The reason they call this like fine-grained authorization is just because you can give access based on very small access to very small pieces, right? Based on individual files, but you can make it arbitrarily large, your permission system. Okay, so with that, just to quickly recap what we've seen. So we've seen essentially this folder hierarchy that I show you here. Again, on the right-hand side, where we have a root folder, and then we have various subfolders. And in the leaves, we have files eventually. So here, results and report or PDF. So we can have an arbitrary level of nesting, and we can share it with groups. We can share it with individuals, which are just, if you think of sharing with an individual, you can just like substitute that with a group of just one person. We have different access levels of just read or write. And we can inherit permissions. So if I give somebody access to accounting, they inherit the permission for all the things in the sub folders and sub files here. And so you may have realized this, but if it's not obvious, but this is a graph, right? It's a tree. It's a special form of a graph, but essentially that's a graph data structure, and that's what it's all about today in this webinar. That's what we're gonna work with. Okay. So with that, let's start and try to see how we can kind of like implement such a fine-grained permission. They also call this FGA in the as an acronym sometimes. How we can implement and model such an FGA system using Feldera as a compute platform. So first attempt, what we're trying to do is we're just going to do this like as if we would do it if we just knew SQL and relations, and we would just try to do this in basic SQL, right? So what one would probably do is to create these three tables, right, to model our entities in the system. So we have users, which are just names here. We have groups, which are also just names. And then we have files, which we just represent with a path here in our table. And now we need to model the relationship between users and groups and users and files. And we can also do that with tables, right? So we can make a table called members. which represents which user is in which group. So a user can be in many groups, and the group can have many users. So this is an M-to-N relationship. We can have a group file editor, which is which file a group can write. And a group can write to many files, or a file can be in many groups. So that's also an M-to-N relationship. And we have the same thing again for group file viewer, which is also an M-to-N relationship, meaning which group can view which files, and which file is in which groups, right? So that's pretty basic, right? So there's just 3 M-to-N relationships here and 3 entity tables. And so if we do that, we look at this, we can kind of see how this would look like. So here on the left-hand side would be our file table again, which where we just have the path, and we just list all the files here with the path. And then we would have the groups and the users as our entities. And so now, right, if we wanted to make a connection here, so if we were to say Rob is part of accounting, we could make this connection like this. And what this would amount to is essentially inserting him in the members tables, right, with the right user ID and the right group ID here. So that's how we would mimic that Rob is in accounting. And we can put Alice in engineering as well by inserting it in the members table, and we can put Ben in engineering. And so now we have populated the members table, for example. And then the next thing we would do is we would say, well, accounting should be able to access the accounting folder, right? Just going to worry about writable permissions here for now. The read is essentially analogous to write permissions. And so in order to make this relationship work, right, what we would do is we would essentially enter in the group file editor that the group accounting can access the file that is represented by this /accounting, so this ID here that we haven't specified. Right, so that's pretty basic, right? Now, in this kind of version, right, so what we're doing is we don't really model this file hierarchy yet, right? So because in standard SQL, turns out you can't actually really model this file hierarchy. So what we did is we just kind of like always wrote the path out here, right, for all the subfiles. So if you really wanted to give accounting access to the whole accounting folder, we would actually have to insert more things here. We would have to add a relation, add an entry into for accounting expenses, right? For accounting quarterly. I'm going to draw all the arrows here to all the accounting files. And so that's how we could kind of model this, right? In this kind of SQL version that we have here, where we just insert all of them, all these things into this group file editor table. So if we want to know whether a user can edit a file, we just query this file editor table. We join it all the way back through group ID and members to find the user, and then we can kind of tell whether a user has permission to access this. Same thing with engineering, right? With engineering, you will just add entries here. Now, this is kind of okay, right? It's kind of an okay model to do, but it has obvious problems, right? So one is like we don't capture the kind of natural path hierarchy, right, of this accounting, that it has the subfolders and stuff. So instead, we just inserted many rows into our group with files, group file editor table, and that's not exactly ideal, right? So especially if you can think of situations where a folder would have like many millions or billions of files, and then changing that or adding a new permission for that would be a very large change to your database, would amount to inserting many of these rows, which are represented as arrows here. Also, if you think about it, like either moving or renaming a folder, right, or moving something around in the hierarchy would cause like very large transactions that would be very hard, I think, to satisfy in a system where you have like many users and many groups and many files, right? So we need a better way to do this. And one better way to do it is if you have a recursive SQL functionality in your system, right? So here's a better way to model the data. And essentially what we did is we left everything the same for users, groups, and for our relationship tables. But we added a parent ID to our files table. And we just changed files table. Instead of like storing the whole path, we store only the leaf of a given node in our tree, right? So instead of like writing the whole path to the report PDF file, it's just called report PDF file. And then the path is implicitly modeled by having this parent ID, right? So what this means really is that we start with our root, which is just a basic folder, and root has ID 0, and it doesn't have a parent, so the parent is set to null because it's the first one. It's the first thing in our tree. And so now accounting, right, because it's inside of the root folder, it has a parent ID 0, which we take from here. Engineering also is in the root folder, so it has a parent ID of 0, and IT also is in the root folder. And then, same thing for expenses and quarterly. They are within accounting, so they have an ID of 1, so we put the parent ID 1 here and here. Report PDF has a parent ID of 4, so it's under expenses, and quarterly it has results.xls, so it's a 5. And then we can complete this here. So designs would be in engineering. So we look what the ID is here, and so I put the 2 here. And webinar is also in engineering, and passwords is in the IT folder, which has a 3 here. So that's it. That's what we do. And so now, right, if we kind of want to find out what's the path for report PDF, right? What does it belong to? We kind of can follow this chain here. So we can go to 4. So we know it's in expenses. And then from expenses, we know it's a 1. So we can go to accounting. And then from accounting, it's a 0. So we know it's in the root. And then once we reach the null here, we know that this is the whole path, right, for report to PDF. So that's it, right? So that's the key part of how we model this graph relationship or this tree of our file system hierarchy using this parent ID field. And so now, right, what would happen is if we want to add Rob to accounting, we would still do exactly the same thing as before. We would insert him into the members table. And let's say if we wanted to give Rob or the accounting group here really access to all of the accounting folder. So all we need to do now is we just need to insert one kind of entry that says in our group can write table that says accounting has access to this folder here with ID 1. Right? And so that's good enough, but the difference is now we can no longer just query the file editor table, right, to figure out whether accounting can access report PDF, right? It just won't be in there. It won't be in this thing. It's implicitly there, by now that what we need to do is we need to write a view, right, that computes all the files that are under accounting, right? And so then we can still do the same thing of trying to figure out whether Rob actually has access to report PDF. And so that's the gist of it, right? So that's the key thing that we're trying to achieve here. Okay, so let me kind of like move a little bit further. So how do we do that, right? So how do we do it if we just have this one fact here in our system where accounting is the folder we're giving write access to, and how do we get to this point where we can say, well, actually report is under accounting through expenses, and so we can write to it. So how do we do that? So we need to think a little bit about it. So first of all, I'm going to write these things down now in sort of a different kind of notation. If you're familiar with something like Prolog, you might have seen this before, but we're going to try to kind of like informally come up with the rule, right? So something is editable, a file or a folder, when it's explicitly set as editable. So if we would have made this connection here and inserted this fact here into our group can write table, that would be this. So this just means if something is set, a group has write access to a file, then we can also write to this file, right? So that's fairly trivial. It's just our base case. And then the next thing we want to model is that the write access propagates to subfolders and files. So the way we would kind of write this in as a rule would be, so if something, a group, can write file 1, and file 1 is a parent of file 2, then we can also write file 2, right? So that's fairly basic, right? If we look at it like this, and maybe one thing I need to mention as well is that we always say file here, right? But we use the kind of the Unix convention where file and folders are essentially the same thing. So you can substitute that with folder too. And so the key thing to note here is, right, that we have this group can write rule or function here on the left-hand side, right, and on the right-hand side, which essentially tells us that this is a recursive relationship, right? So we need to model this, if we wanted to kind of write this as in any really code, really, we could use recursion to do this, or we would have to use some form of an iterative solution or recursive solution. And so in standard SQL doesn't really know this, right? But there's many systems which have recursive SQL functionality, and Feldera is one of them too. And on top of that, Feldera has like an incremental evaluation of the SQL, right, which makes it really nice for these permission systems. And so that's what we're going to do in the second half of the talk, is we're trying to build some SQL now in Feldera that essentially does what we just discussed for the last 5-10 minutes. So building a permission system like this one. So I'm going to switch out of the slides. I'm going to go to our web console here in Feldera, and I already pre-populated the SQL code. And so let's just look at some of it for the sake of brevity here. So I'm also just gonna like discuss the write case. The read is very similar. But we have these tables that I just showed you in a slide earlier for users, groups, and files here. And then we have our relationships for members, group file editors, and group file viewers. And now this is the interesting part, right? The part we just discussed. Now we have this view, which is a recursive view, and we call this the group can write view, right? So this determines which group can write to which files. And so this group can write view, right? In Feldera SQL, if you want to make something recursive, first you have to do something called a forward declaration, where you just declare the name of the view. You declare that it's a recursive view, and you say what this view returns, essentially, right? And so the key thing is that once you do that, within the view itself, right, you can reference that view again to look up from it, right? And so that defines the recursion that you're doing in the Feldera SQL. So this is a really kind of a neat and short way to write recursive query, which is close to how most people are used to it from like other languages. Okay, so let's look at this recursive view group can write that we just declared here. So this essentially can be split into two cases, right? So you can think of a view as always of something that returns a set, right? In SQL, everything is really sets. So we make an initial set using our rule 1 that we discussed here. And the initial set is just, we look everything up from our group file editor table, right? So all the facts, like if somebody would have said like, yeah, counting is writable and like added that permission explicitly, then this would be returned by this query here, right? From this select from group file editor table. And then the second rule, right, is saying, well, okay, starting from this set, we do union all. So all the sets that we're getting, on top of that, we're going to just merge them or combine them together by using union. And what we're doing is we're essentially looking up, we're taking the files we got here, or folders, and we're going to expand that by following those files, finding everything that had a parent ID set that was from a file that we found from here, And then we just add that to our set, right? And we do that recursively because we're specifying here the same view again. We're selecting from the same view that we're actually declaring as well at the same time. So maybe to make this a bit more understandable, let's look at the kind of concrete example, right? So I'm going to switch back to my slides. So in this case, if we added here this fact, right, to our table, that we can write this. So this would be in our initial set in that first case that we saw. And then what Feldera would compute recursively is it would look up what is the ID of accounting, 1 here. It would go and find everything that has parent ID set to 1 here, and add it to our set, right? So if this is our initial set, this would be our next set that gets added. And then given that it finds 2 new IDs here, 4 and 5, it would also try to find them in the table, look at which files have the parent ID 4, and it would find this one as a new set and this one as a new set. And then it would look for 6 and 7 as the parent ID in our table. It would find that nothing here has a parent ID set to 6 and 7. And so essentially what this would mean is for the recursion is that it wouldn't change, right? When it executed this step, the recursion didn't change anymore. So which means it would become stable, right? So in this case, it would abort in the computation. Right, so that's it. That's essentially what this query here does. Right? And we can see the right case. You can study it yourself. I'm going to give the link to the tutorial in the end, but it's a very similar case. I think the only difference in writing is that actually what we also model is that if somebody already has a write access to it, he can also read it. Sorry, the read case I mean is very similar to the write case. All right, so let's just have a look and start this up. So, and we're gonna essentially add some queries. So we have our model now, our permission, fine-grained permission model added to the system. And I'm gonna first populate files, groups, and users in the system by taking some SQL I already prepared and just pasting that into our query engine. So I'm also enabling here the change stream. So the way Feldera works is based on changes. So whenever you make a change to a table, it will output what it changed in the table, and it will also output how the view changed by either emitting deletes or update or insert or delete statements that we can see here when we activate them in the change stream. So for now, we just activate the files table because we're going to insert something in the files. And if I execute this statement, we see that immediately Feldera emits the changes for the file table by essentially saying, hey, you inserted those 10 files into your system, or 11 files, start at 0. Okay, so we're going to continue. We're going to insert some groups as well. So we have 3 groups, the accounting, the engineering, and the IT department that we just saw. I'm going to enable the change stream for groups so we can see that as well. Okay, so we inserted the groups, and I'm going to insert users. I'm going to enable the users view for the changes. So we inserted our 3 users, Rob, Alice, and Ben. And now we need to make some relationships between groups and users and files. So we're first going to put Rob in engineering, Rob in accounting, sorry, Alice in engineering, and Ben in IT, right? So each of your users gets put in different groups. So if I enable that, I can see we made these relationships work here by populating the members table. And finally, this is now the key part. So now we're saying, well, we're going to give permissions, right, to certain folders. So we're going to put this in by populating our group file editor table. So the permissions are, we're going to give the accounting group edits to /accounting. We're going to give the engineering group edit right to /engineering, and we're going to give IT rights rights to /edit. Right? And so we have obviously our group can write table, group can write view, which populates everything. But actually, we have a slightly more a slightly nicer views using user can write, and I didn't actually explain this properly, but the user can write view is nothing special. It's exactly the same as the group can write view, but it's just joins it back to the user ID and the username, so we can go and display what user can actually access which files. Right, so all the magic happens really in group can write, and but our user can write view is just a better representation that has all the information of the user too in it. So in Feldera, you can nest views on top of other views, and you can do that very deep nestings. So it doesn't really affect performance much for us. So it's a nice way to kind of like encapsulate your SQL, making every view very small, and then building on top of other views. Okay, so enable this user can write view, and so now we're going to insert the permissions, and that should allow us now, if our model worked correctly, it should give us a means to see that we like transitively, right, can reach more files than just these top folders here. Okay, so we make the insert, and we see now Rob, he gained write access to the accounting folder, but he also gained write access, right, by recursively evaluating our group can write view to expenses, to quarterly results, to report PDF, and to result XLS. And Alice, in turn, is in engineering, so she gained access to everything under engineering. And Ben from IT gained access to everything from IT, right? Okay, so that's nice. So our recursion works. So now we can also kind of make some changes, right, and see how that behaves. So we're gonna make sure we're gonna add Alice. Alice is a member of engineering, and now we're gonna insert another change where we say Alice is not just a member of engineering, but Alice is on top of being an engineer. She also does IT work, so she really should have access to the IT group. And we're gonna see what happens if I do that insert. Here, smaller. So if I do this, right, so we see that Alice also gained permissions to access everything under IT. So whenever we make a change, right, to our permission model, what Feldera does is will do work proportional to the change that you make, and it will emit the changes to any view. So we could enable more views here, but we're only looking at this one right now. It will emit the changes that it made to any of the views or the table to you in a minimal way, so that you can take those changes and do something with it in your system, enforce the permissions, for example, in this case. Okay, so here, last case I'm going to show is just doing something through the HTTP console. So I'm going to invoke a curl command that does two things. So first, it deletes the password permission or the password file, and then it reinserts it, the password file, but it changed the parent ID, right? So it moved essentially parents from /ID passwords to /accounting, right? So we're going to do that. Going to invoke this curl command and going to watch what happened to the table. So now you can see we're not just having an insert here for a new user. So we got two deletes on top of that. So this was already from the previous execution. And so the new execution that I just did on the curl command, it removed permissions for Alice and Ben, who are in the IT group, to access this passwords file. And then it inserted the new kind of write permissions for Rob, who was in accounting, to access this file, passwords, PDF, right? Passwords.kdbx file here. So that's essentially it. That's the gist of this permission model. So we see how we can kind of model this using recursive SQL. We saw a little bit how it works using changes in Feldera and how making changes to the system gives you a minimal amount of insert and inserts and delete statements or change stream from the Feldera system, where you can act on it. Okay, so that's so much for my demo. I'm gonna switch back to the slides for a second here. Okay. So that's essentially all I wanted to talk about in this webinar today. So we do have a tutorial on docs.feldera.com that has more in-depth explanation of what I just showed you, what we just talked about today. The link is here, and I just want to mention